The next one is composite numbers. Okay, next one is what? Composite numbers. Okay, how many composite numbers we have, and what is the composite number? Okay, composite number means that what? Composite number is nothing but the numbers which are not prime numbers are called composite numbers. And there is another standard definition for the composite numbers. Any number which has more than 2 factors, that number is called a composite number. So what is the definition of prime number? Any number which has only 2 factors. Composite factor means that any number which has more than 2 factors, those numbers are called composite numbers. So suppose if I take that some number 4. What are the factors for 4? 1, 2, 4. How many factors we have? 3 factors, which is more than 2. Right? Similarly, suppose if I take 10. So how many factors we have? 1, 2, 5, 10. So the number of factors are more than 2, right? So we can say that 10 is what? A composite number. 4 is what? A composite number. So composite number must have more than 2 factors. And we have already discussed that 1 is neither prime nor composite, because 1 does not have 2 factors or more than 2 factors. 1 has only 1 factor. That's why 1 is neither prime nor composite. Clear? Okay, let's see another one. Another type of numbers, that is twin prime numbers. So what is prime number? Prime number must have only 2 factors. Then there is another one, that is twin prime numbers. So twin prime numbers is different from prime numbers. What is twin prime numbers? So twin prime numbers are nothing but if the difference of any 2 prime numbers is 2, then those 2 prime numbers are called twin prime numbers. Okay, sometimes the questions will be asked like which of the following numbers is the twin prime numbers? Okay, or which of the following numbers are the co-prime numbers, or which of the following numbers are composite numbers? Okay, so definitions are also important. Okay, but don't by heart them, just logically remember them. So twin prime number means that if difference of 2 prime numbers is 2, then those numbers are called what? Then those numbers are called twin prime numbers. So if the difference between 2 prime numbers is 2, those numbers are called what? Twin prime numbers. What is the term? Twin prime number. So suppose if I take the example 3 and 5. Okay, can I call these 2 or prime numbers twin prime numbers? Yes, because 3 and 5 are what? Prime numbers. What is the difference between these 2 numbers 3 and 5? The difference is 2, right? So I can say that 3 and 5 are what? Twin prime numbers. And similarly, suppose if I take another one, 11 and 13. What is this 11 and 13? Again, 11 is a prime number, 13 is a prime number. The difference between 11 and 13 is what? 2. So 11 and 13 are what? Twin prime numbers. What are these numbers? Twin prime numbers. You take any number 17, 19, all these numbers are called twin prime numbers. The same thing we can represent in other way. If there is only one composite number between 2 prime numbers, those numbers are also called twin prime numbers. Definition, so you will not be asked the definition, but you can remember it anyway. So as per this definition, if we have only one composite number between 2 prime numbers, so 3 is a prime number, 5 is a prime number. So what is the middle number? Between 3 and 5, I have the number 4. 4 is which number? Composite number. That is what the definition is. Both the definitions are same. Both are not different. Okay. Either we say that if between 2 prime numbers, if we have a composite number, then those 2 prime numbers are called twin prime numbers. Or else, if the difference between any 2 prime numbers is 2, then those numbers are called what? Twin prime numbers. So the examples are 3, 5, 11, 13, 17, 19. Okay, you can take 71, 73. All these are what? Twin prime numbers. Is it clear? Okay. Let's take another one. Co-prime or relative prime. Co-prime, next one is what? Co-prime or relative prime. Don't confuse with the terms. So we have the prime numbers. Prime number is different. Next, twin prime numbers. Twin prime numbers are different. And the next one is co-prime or relative prime. Co-prime or relative prime. So this is different one. All these three are different to each other. Okay. So prime number is different, twin prime number is different, co-prime or relative prime are different. Okay. Now by the way, so now we'll see what is co-prime or relative prime. Both the terms has the same meaning. When I say that co-prime or relative prime, both are same. And this is a very important concept. And we have a separate topic on co-prime and relative prime that will learn it in the coming classes. As of now, we just see the definition of co-prime or relative prime. Okay. Okay, if two or more numbers have only one common factor, those numbers are called co-primes or relative primes. So if two or more numbers, so let me take some example like 3 and 4. If two or more numbers, so first in this example I take only two numbers. Okay, so two or more numbers have only one common factor. What is that? One common factor. Then those numbers are called co-primes. So how many common factor we should have? If we have only one common factor for the given numbers, then those numbers are called relative primes or co-primes. Okay, anyways, we see what are the numbers, what are the factors for 3. So if you write factors for 3, what are the factors for 3? 1 and 3. What are the factors for 4? I have 1, 2, 4. Okay, the factors for 3 is what? 1 and 3. So because 3 is divisible by 1 and 3. 4. What are the factors for 4? 1, 2, 4. Now you tell me that. So which is the common number? Which is the common factor? So this is a factor and this is also a factor. Which is the common factor? 1. Okay. So if two or more numbers have only one number as common factor, that numbers are called co-primes. So which means that, so how many common factors we have? Only one. And also that common factor is obviously 1, because 1 is divisible by, any number is divisible by 1 only, right? So the common number is obviously 1 only. Okay. So if two or more numbers have only one common factor, those numbers are called co-primes or relative primes. You see for 3 and 4, so the factors for 3 is 1 and 3, the factors for 4 is 1 and 2 and 4. The common factor is only 1. There is only one common factor. So I can say that 3 and 4 are what? Co-primes. Okay. So 3 and 4 are what? Co-primes. So here you remember one more point. So just because I say that, so co-prime, it does not mean that both the numbers we have must be prime numbers. Okay, we have nothing to do with the prime numbers. Prime numbers are absolutely different from co-primes. Okay, even though the term has prime, it is not related to the prime numbers. Okay, we can have the prime numbers, or we can also have the composite numbers, or we can also have the combination of both prime numbers and composite numbers. Here 3 is a prime number, 4 is a composite number, but still 3 and 4 as a pair is a what? Co-prime, because so we have only one common number. Okay, let's take another example. Suppose if I take another example. Okay, suppose if I say that 6 and 9, suppose if I take 6 and 9, can I say that 6 and 9 is a co-prime or a relative prime? Okay, let's see this one. 6 has factors of what? 1, 2, 3 and 6. What are the factors for 9? So it is divisible by 1, 2, sorry, this is not divisible by 2. So 1, 3, 9, right? Now, as per the definition, we should have only one number as the common number. One number as common number. So, but here in this list, 3 is also a common factor, right? So that's why we don't say that 6 and 9 is a co-prime number. Suppose if I take the example of 4 and 9, can I say that 4 and 9 is a co-prime? Yes, we can say, because we have only one common number, only one common factor. So what are the factors for 4? This is divisible by 1, 2, 4, 9, 1, 2, 4, and 9 is divisible by what? 1, 3 and 9. 1, 3 and 9. So which is the common number? 1 is the common factor. So we have only one common factor, right? So that's why we call this as co-prime numbers. Co-prime numbers. Clear? So likewise, So likewise, if we have only one number as the common factor, so those numbers are called coprimes or relative primes. You see the difference between prime numbers? Prime numbers means that, so any number which has only just see the definition of prime number. Okay, any number which has only two factors, that is 1 and the number itself, that number is a prime number. Prime number is absolutely different from the twin prime. Twin prime means that what? Twin prime means that the difference between any two prime numbers is what? 2. Okay, then those numbers are called twin prime numbers. But for twin prime numbers, both the numbers must be prime numbers. Okay, and the next one is relative primes. Relative primes means that, so you take two numbers or more than two numbers. For all those numbers, if we have only one number as common factor, that is 1, okay, those numbers are called relative primes or coprimes. For 3, 4, we have only one common factor. Suppose if I take 6 and 9, for 6 and 9, I have two factors. Okay, 1 and 3 and 1 and 3 are common. So that's why 6 and 9 are what? Not coprimes. But 4 and 9 are what? Coprimes. Okay, even though 4 and 9 are composite numbers, we say that 4 and 9 are what? Coprime, because both the numbers has only one common factor. Okay, you always see the definition like that. Okay, only the definition is two or more numbers has only one common number, only one common factor, right? Clear? By the way, so we have different kinds of problems related to the coprimes or relative primes. So that we will discuss in the class related to the coprimes and relative primes. Okay. Now the next number is perfect number. A perfect number. What is a perfect number? A perfect number means that, so suppose if you take a number, okay, so the sum of the factors for that number except that number is equal to the given number is called a perfect number, which means that, suppose if I take number 6, okay, what are the factors for 6? So the factors for 6 is 1, 2, 3 and 6. Okay, now a perfect number is nothing but the sum of the factors except the given number, so which means that what is the given number? 6 is equal to this number. So now accept the number, so if you add the remaining numbers, 1 plus 2 plus 3 is what? 6. Okay, this is the given number, right? Now this number 6 is called what? A perfect number. 6 is what? A perfect number. If the sum of all the factors of a number except the number is equal to itself only, that means that the number itself only, that number is called a perfect number. So suppose if you take the example of 6, the factors are 1, 2, 3 and 6. The sum of these numbers 1 plus 2 plus 3 is what? 6. Okay, you don't take the number again, you don't add the number itself again, and except that number, the sum of the remaining numbers is equal to what? 6. And also suppose if I take 28, what are the factors for 28? 28 means that I have the factors, see, I'll write it here. So 28, the factors for 28 is, I have 1, 2, 4, 7, 14 and 28. Okay, accept this number, add the remaining numbers. 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 7 is what? 14, 14 plus 4 is 14 is what? 28. Accept the given number, the sum of the remaining numbers, 1 plus 2 plus 4 plus 7 plus 14, which is equal to what? 28. Equal to the same number, right? So that kind of numbers are called perfect numbers. Okay. So by the way, so we have the perfect numbers examples as 6, 28, 496, 8128. Okay, so we have only one single digit number, such number, and we have only two digit number as a perfect number wise, that is 28. And if you take 3 digit number, in the complete 3 digit numbers we have only 496. In the complete 4 digit number, what is the 4 digit number which is a perfect number, which is nothing but 8128. So perfect number. Okay, so by the way, so we had found out only 27 perfect numbers up to now. Okay, so in the complete numbers, in the complete ocean of numbers, we can have 27. We found out that only 27 numbers are perfect numbers. Out of them, these 4 are the most important examples. So you can remember this one. Okay, so these 4 are the most important numbers, perfect numbers. By the way, so till now we have found out that only 27 perfect numbers in the complete numbers. In the universe of numbers, we have found out that only 27 perfect numbers. Okay, by the way, you remember the definition. Okay, the next one is place value and the face value. What is place value and the face value? This is a very simple one but very important one. Here, place value means that, so the value of each digit in the number, which means that suppose if I take the 2, 3, 4, 5. Okay, suppose if I ask you that what is the place value in the number 2, 3, 4, 5. Place value means that, see here, suppose if I take 5 is in which place? Unit place, right? 4 is in which place? 4 is in tens place. 3 is in which place? Hundreds place. 2 is in which place? 1000 place, right? Suppose if I ask you that what is the place value of 2, so 2 is in which place? 2 is in thousands place, so your answer is 2 into 1000, which is what? 2000. So 2000 is your answer. Is it clear? A place value is nothing but the value of each digit in the number. And similarly, suppose if I ask you that what is the place value of 3 in this number 2, 3, 4, 5. So 3 is at which place? So 5 is in units place, 4 is in tens place, 3 is in which place? Hundreds place. So the place value is 3 into 100. So 3 into 100 is what? So 300. So 300 is your answer. Okay. Suppose in the number 45621. Okay, so what is the place value of 5? Suppose if I ask you that what is the place value of 5. So place value is nothing but first you have to count that. So first you have to see at which position that particular number is there. So this is unit, tens, hundreds and thousand. So 5 into that number into at which place it is? It is at the thousands place. So 5 into 1000 is what? 5000. So answer is what? 5000. So this is what place value means. Okay. Now there is another one, that is face value. Face value is that nothing but the digit itself is your answer. Okay. So face value is the actual value of the digit. Okay. Suppose if I ask you that what is the face value of 2 in 2345. Okay. So here 2 means that simply you write that number only. Suppose if I ask you that face value is nothing but the digit itself only, that answer. Okay. In the 2, 3, 4, 5. So what is the face value? The face value is 2. Irrespective of at which place it is. Okay. Irrespective of at which place that particular digit is, your answer is the digit itself. Okay. So what is the face value of 2? The face value of 2 in the number 2, 3, 4, 5 is 2 only. Suppose if I ask you that what is the face value of 4? What is the face value of 4? The face value of 4 in any number is 4 only. Okay. So 2, 3, 4, 5, the face value is what? 4. You take any example. See, remember that place value means that, so multiply with that the particular number at which position. Okay. Suppose if it is asked for the face value is nothing but the digit itself is your answer, no matter at which position it is. Okay, is it clear? A simple thing but very very important one. So it was asked couple of times in different exams. Okay, what is the place value of a particular number? What is the face value of a particular number? Face and place. But don't get confused. Place means that at which place a particular number, multiply the digit with that particular place. Face value means that the digit itself is your answer. Okay, so this is about the different types of numbers. Okay. And in the next session, we are going to learn about different things, different types of problems in the number system. Okay, thank you.